Welcome, students. Today in JSS 2 Basic Technology, we are studying two very important precision measuring instruments, the Vernier Caliper and the Micrometer screw gauge. In technology and engineering, accurate measurement is essential. A regular ruler can measure to the nearest millimeter, but many engineering parts need to be measured much more precisely, sometimes to 100th of a millimeter. This is why we use the Vernier Caliper and the Micrometer. Let us start with the Vernier Caliper. A Vernier Caliper is a measuring instrument that can measure the external dimensions of objects, internal dimensions, and depth. It consists of two main parts, the main scale, which is fixed and reads in millimeters, and the sliding vernier scale, which slides along the main scale and gives the additional decimal reading. The most common Vernier Caliper used in Nigerian schools measures to an accuracy of 0.02 millimeters. This means it can detect differences as small as 200ths of a millimeter. Here is how to read a Vernier Caliper. Step 1. Read the main scale. Look at where the zero line of the vernier scale falls on the main scale. Read the number of whole millimeters to the left of the vernier zero. Step 2. Read the vernier scale. Look along the vernier scale to find which line on the vernier scale lines up exactly with a line on the main scale. Multiply the number of that line by 0.02 millimeters. Step 3. Add the two readings together to get the final measurement. For example, if the main scale reads 23 millimeters, and the seventh line on the vernier scale lines up with the main scale, then the reading is 23 plus 7 times 0.02, which equals 23.14 millimeters. The Vernier Caliper has several parts you should know. The outer jaws measure external dimensions such as the width of a block or the outer diameter of a pipe. The inner jaws measure internal dimensions such as the inner diameter of a hollow tube. The depth probe, which is a thin rod at the end of the caliper, measures the depth of holes on slots. The locking screw holds the caliper at a fixed reading so you can read it without it moving. Now let us study the micrometer screw gauge. The micrometer, or micrometer screw gauge, is even more precise than the Vernier Caliper. A standard micrometer measures to an accuracy of 0.01 millimeters, 100th of a millimeter. This makes it suitable for measuring very small dimensions like the diameter of a wire or the thickness of a thin sheet of metal. The micrometer works on the principle of a screw. One full rotation of the thimble, the rotating part, moves the spindle by exactly 0.5 millimeters. So by counting fractions of a rotation, we can measure very small distances. The parts of a micrometer include the frame or U-shaped body, the anvil, which is the fixed flat surface, the spindle, which moves toward the anvil to grip the object being measured, the sleeve or barrel, which has the main scale engraved on it in 0.5 mm divisions, the thimble, which rotates and has 50 divisions on it, each representing 0.01 millimeters, and the ratchet stop, which prevents over-tightening and ensures consistent pressure when measuring. To read a micrometer, Step 1. Read the sleeve scale. Count the number of 0.5 mm divisions visible on the sleeve. Step 2. Read the thimble scale. Find which thimble division lines up with the horizontal reference line on the sleeve. Multiply by 0.01. Step 3. Add both readings. For example, if the sleeve shows 7.5 mm and the thimble reads 23, the total is 7.5 plus 23 times 0.01, which equals 7.73 mm. When using both instruments, handle them with care. Never force them onto an object. Always clean the measuring faces before use. Store them in their cases to protect them from damage and rust. In Nigerian workshops and in your WAEC and NECO examinations, you may be asked to read measurements from diagrams of Vernier calipers and micrometers. Practice these readings regularly until you can do them quickly and accurately.